Hi class. We have one last thing to discuss in 3.4, and that is standard deviation. So this tells us the average deviation from the mean. So in other words, it's talking about, like, if we just look at 49, how far away, how many deviations is it from the average that we found? All right, because if it's really, really far away, then that lets us know something. And especially if this is a symmetric distribution, that tells us even more. And we will get into that later. But for right now, we are going to calculate by hand the standard deviation. And we can use Excel for this, and I will show you that in another video. But I want you to be aware that I will require you to find it by hand on your final exam, okay? Not with quite this many sets of data, too time consuming, but with like 5 pieces of data or something. So I have the data here. It's listed in order. Here is this wonderful formula for standard deviation. I will give you this formula. You, however, have to know what the heck it means, okay? So this symbol right here, this cool little like big E in a way, this is known as sigma. That's the Greek letter sigma. And it means the sum. So it's really nice to write that Greek letter, because then you don't have to write out that you're adding all these values up. So this is saying, okay, I have to take here's your data point, you subtract it from the mean, and then you're going to square it. All right. Then you divide it by one less than the set of data that we have. And then at the very end, you take the square root. Okay. And this we will go further into in another video. But for right now, we're just learning a formula. So the deviation from the mean. So I have 49. What I need to do is I need to subtract 49. So I take the piece of the data, so that's my x, take away, well, actually, let's remind ourselves what the mean was. Let's see if I still have it up here. Going. Did I find it in these notes? I think they're in my other notes, but I have it written down. Yeah, we didn't find it in 3.4. We found it in 3.3, if you can remember, because we were still talking about this set of data for the Math 95 exams. So let's just remind ourselves, our mean is 73 points. Or you can find it again if you really want by adding everything up and dividing by, and I believe there's 19. Okay, so we have 49 minus 73. That will give us negative 24. So I have to do this. I'm going to go down this entire column doing this. Okay, well, 49 minus 73, again, is negative 24. 52 minus 73 is negative 21. 58 minus 73, and keep them negative because it does affect some other answers. Negative 15. 62 minus 73 is negative 11. And you can pause this video and find these on your own if you'd like, because this is going to be kind of boring. 66 minus 73, negative 7. 67 minus 73, negative 6. 71 minus 73, negative 2. 73 minus 73 equals 0. So let's make sense of that. Remember, standard deviation, and we haven't found it quite yet, but this is talking about just this column is just doing deviation from the mean, so how far away we are from the average. And it makes sense if our data is 73 and it's the same as our mean, we're 0, right? We're right on the average. 74 minus 73, 1. 75 minus 73, 2. 78 minus 73, 5. You can see why I want to give you this much data on an exam. 81 minus 73, 8. 82 minus 73, 5. 84 minus 73, 11. Did I mess something up? I sure did. Sorry. That's not a 5. 82 minus 73 is a good old 9. Okay, now I'm at 85 minus 73 is 12. 86 minus 73, 13. 91 minus 73, 18. 96 minus 73, 23. Okay, now, so we found the deviation from the mean, how far away this data is, how many points this data is from the average. Now I need to square all of these values. So negative 24 squared, and I would use a calculator, 576. Just make sure in your calculator you put these parentheses, negative 24 squared, 576, negative 21 squared. These ones I don't know. There are some that we have memorized. Negative 15 squared, I know this one, 225. Negative 11 squared, 121. Okay, so now we're getting into some values. Hopefully you feel confident about knowing these squares. 49, negative 6 squared, 36, negative 2 squared, 4, 0 squared, 0, 1 squared, 1, 2 squared, 4, 5 squared, 25, 8 squared, 64, 9 squared, 81, 11 squared, 121, 12 squared, 144, 13 squared, 169, 18 squared, I would have to use a calculator, 324, 23 squared, 529. All right, so now what we need to do is we have to add, and we won't have enough room to, we need to add this value with this value, 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 this, this. So you definitely want a calculator. So I'm going to just put in our notes so we know where this thing is coming from. We're doing 576 plus all the way up to that last one, 529. And you can use a calculator or Excel or Google Sheets. But to save us time, I don't think I need to show you how to do that on a calculator. We get 3,490. All right, we have not used the formula yet. We're finding it step by step. So now the formula says you take the square root. Remember, this piece is what we found right here. Let me give you a different color, actually. This is this. Okay, because this piece, remember, means the sum. Let me just draw, just so it makes sense again. All right, so we know that, and realize we've already, another thing I want to point out, we've already squared them, right? Look, we squared all those values, so we don't need to square this thing again. So this is 3,490 divided by, well, how many data points do we have? We have counted it up in another video, so I just know it's 19. So that's our n. is how many, let me just, so you know what this is coming from, how many data points there are. We always subtract one less than what you have. So that's why we are going to divide by 18. All right, so if I do this in my calculator, and let me just see. Yeah, I don't have sheets open. You would divide it and then take the square roots. I think I should show you that. I'm going to leave that for another video for some technology. If I do this correctly, I get 13.92 points. So remember units, we've talked about that. And this would always be the same units as your data. Okay, and it's not squared because you took the square root of it. So what that's telling you is your standard deviation for all this set of data is about 13.92 points away from that average of 73. So let's make sense of that. Remember also it's the average deviation. So we had to take all the set of data, add it up, and get the average deviation. So it's not exact, it's just the average. So we're claiming the average set of deviation is 13.92 points away from that mean of 73. And again, we're going to get further into this, but right now it's just learning terminology and the formula. Okay. Now, there's another way we could do this, and it was discussed at the very top. It says range divided by 4 if the data is evenly spread without outliers. So what that means is this would have to be symmetric. Okay, that's what I mean by evenly spread and without any outliers. So some of us looking at this data would be like, I have no clue if it's symmetric, right, or evenly spread. We already know actually it's not because we created that histogram in 3.3. But let's just compare the two. If I was going to find my range, remember that is your max take away, our lowest is 49. And so we get 47. Okay, then I'm going to take 47, divide it by 4, and I get 11.75 points. Well, that is not really the same as 13.92, right? So what we know then, since it's not close enough, we know the spread so let me rephrase this. We know, let me get rid of this. It is not evenly spread. In other words, symmetric, which we already knew, but just in case you didn't. We knew from 3.3 it is skewed left. Okay, so that's just getting our toes wet, and I'll see you next time to dive more into this.